Well, hey guys, I just realized that my audio did not transfer over on my videos for two of them for week 6. So what I'm going to do is to attempt to redo the videos with my audio dubbed in. So guys, in week 6 we are learning how to factor. And we're talking about the GCF. That's the greatest common factor, the greatest factor that divides each term. So in the first example, you see that we are trying to find the greatest common factor between 36 and 48. Your first step is to write out all of your factors for each number. For example, 36 is 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. We can do the same thing for 48. 1 times 48, 2 times 24, 3 times 16, and 4 times 12, and then 6 times 8. To locate the greatest common factor, we find the largest number that's in common with both of our lists. And we see that 12 is the largest number that occurs in both lists. So our greatest common factor of 36 and 48 would be 12. As we move on to the second example, when we're finding the GCF of variables, the greatest common factor is the smallest exponent. So the greatest common factor of the x cubed and x squared is x squared, because 2 is the smallest exponent between the 3 and the 2. GCF for y between y and y to the fourth is just y, or y to the first. That's the smallest exponent. And then for the z, notice that there's a z in the second one, but there's not a z in the first one. So we cannot include z in our GCF. So our GCF, greatest common factor, is x squared y. And now for the third example, we're combining the two. It's just like combining the first and second example, to where your first step is to identify the GCF of your constants. You're finding the GCF between 5, 25, and 15. And if you look at, write out the list like we did in example 1, you should see that the GCF is 5. That's the largest number that divides into all three numbers. And then you want to do the same strategy with your variables. Your smallest exponent between x cubed, x squared, and x is your x to the first. GCF between your y's, you've got the exponents 3, 2, and 2, so the GCF is y squared. And then for your z, you have z squared, z cubed, and z to the fourth. Your smallest exponent is 2. So your GCF for this problem is 5x y squared z squared. But now going a step further, we're asking to factor this. We found the GCF. So now we write the GCF out front, the 5x y squared z squared. And now we're going to write whatever we have left over inside the parentheses. So what we're doing is we are dividing each term by that GCF, as I'm demonstrating here. And then you're going to do your division, keeping in mind that when you divide, you subtract exponents. X cubed divided by x is x squared. And then y cubed divided by y squared is y to the first. Your z squares cancel. You can do the same procedure with the remaining fractions to give you 5xz. And then finally 25z squared.